All right, guys, in this video, we are going to learn about reflections on the coordinate plane. This is the second type of transformation that we're learning this week. Earlier this week, we learned about translations, which were sliding a figure or an image on the coordinate plane, and a reflection is more like a flip, so flipping something on the coordinate plane. As I go through the notes for this lesson, you need to be following along in your own notes packet. So go ahead and get that packet out if you have not already. This is the packet that you received in class on Wednesday. I told you don't lose it. It's going to be all our notes for this unit. So go ahead and get that out. If you already managed to lose that packet, there is a digital version of these notes packets posted on Canvas. You can search under assignments for chapter 6 notes, and you should be able to find that, and then you'll be able to edit it on your computer using Kami for your notes. If you were absent on Wednesday and you do not have the packet because you were not at school on Wednesday to get it, you can ask the substitute today and they should be able to give you a packet. There are just a few extras left. They are on the lab table at the front of the room. If the substitute can't find them, you can help. So if you were absent on Wednesday and you do not have a packet, that's where you would find one. So like I said, we should all now be on this page of your packet titled Reflections on the Coordinate Plane. This is the third page in your notes. So first we're going to talk about what a reflection is and what it does. A reflection, our keyword here is flips. It flips a figure over a line of reflection in order to create a mirror image. Okay, so we're creating like a mirror image by flipping an image over a line of reflection. And each reflected point of the figure should be the same distance from the line of reflection, but on the opposite side. So on the opposite side of the line of the reflection, it's just the same distance away. So in these first two problems here, you can see it says highlight and identify the line of reflection in each of the examples. Well, the line of the reflection is really just the line that your image is flipped over. So here in this first picture, we can tell this is flipped over the x-axis. Our image kind of flips. You can see it kind of folds over there, and when you have a piece of paper, it's even easier to see. You could even kind of fold your paper on that line of reflection, and you would be able to see those two images matching up with each other. In the second image, we can kind of see that our image is reflected now over the y-axis. And we can kind of tell here that this is a reflection and not a translation, mostly by looking at the corner of the smile there. Here in this first one, the smile's kind of tilted to the left, but here in the second one, it's more tilted to the right. If this was a translation, if it had just slid over, that would not have changed. That wouldn't be backwards. But here, this is like a mirror image because it flipped over that y-axis. Just kind of a quick preview here of what a reflection is. And then we're going to go ahead and scroll down here to this first example. And we're going to do a reflection. It says, reflect the figure shown over the y-axis. Record the coordinates of the pre-image and image. So we're taking triangle W, X, Y, Z, and reflecting over the y-axis. If it helps, you can always label those axes to remember which is y and which is x. Here, our y is our vertical axis. So we're flipping over the y-axis. That means each point is going to be the same distance from that line of reflection. So when I reflect W over that line, it needs to be the same distance away, but on the opposite side. So we can see that W here is 2 units to the right of that line of reflection. That means its image, W prime, is going to be 2 units to the left of that line of reflection. I'm going to go ahead and label there W prime. For Y, kind of the same thing. Y is 2 units to the right of that line of reflection, so I'm staying at that same height, And I'm just going the opposite side there and making my y value. So the image of y, or y prime, is going to be right here on our coordinate plane. For x, kind of the same idea. We can count to see how many units x is from the line of reflection. We get 1, 2, 3, 4, 5, 6, 7 units. Or we also could have seen that just by looking down and seeing that the x coordinate was at 7. And 7 is, of course, 7 units from the y-axis. So I'm coming right back here up to that same height where it was, and now I'm going 7 units to the left of that, and I'm making my point and labeling that x prime. Now I've got all 3 points. I can go ahead and connect those to get my figure or my image. And you can see that this really does look like a mirror image. On your piece of paper, you could actually fold your piece of paper on that line of reflection and you would see those 2 images match up completely. That's one way to check that you made your reflection correctly. If when you fold on that line of reflection, your 2 images do not completely match up, you might have made a mistake somewhere, or you probably did make a mistake somewhere. All right, now that we've got that reflected, we are going to go ahead and see if we can find a pattern about how our coordinates change, just like we did when we were talking about translations. So here for our pre-image, remember pre-images are original, the one that's here in black. Our pre-image is triangle WXYZ, or I'm sorry, WXY. And so we are starting by listing out those coordinates. W here is at the point 2, 6. X is at the point 7, 4. And Y is at the point 2, 2. So that's my original or my pre-image. And then for my image, I have triangle W prime, X prime, Y prime. And W prime is at the point -2, 6. -2, 6. X prime is at the point -7, 4. And Y prime is at the point -2, 2. And the next thing we're going to do is we're going to look and see if we can find a pattern between those X and Y values. And so when we look there, our X values, we start at 2 and go to -2 for point W. We get from 7 to -7 and 2 to -2. Hopefully that's pretty obvious of a pattern there. Our numbers all changed in sign. Here we had +2, 7, 2. Here we have -2, -7, -2. So the X values change sign. Got a little messy there, trying to write with my finger. Let's see, change sign. And the Y values, when we look at our Y values, we have 6, 4, and 2, 6, 4, and 2. So we can say Y stays the same. Stays the same. So if I was going to write an algebraic representation for that, remember that's kind of like writing an ordered pair. Our X value changed in sign. The way that we would say that would be we have that same X value, but if we're changing sign, that's like multiplying by a -1. So I'm going to put a negative sign out in front of it to change the sign of the X value. Y stays the same. So really our Y coordinate is just Y. Whatever Y is in the pre-image, Y will be the same value in the image. All right, we're going to go ahead now and we are going to look at this second example. So right here, it says reflect the figure shown over the x-axis. Record the coordinates of the pre-image and the image. So very similar problem, but the difference is that we are reflecting now over the x-axis. So for the x-axis, that is our horizontal axis. So now, instead of reflecting to the side, we're actually reflecting this up above the x-axis. But it's the same concept here. D is 2 units below that line of reflection. So when I plot its image, D prime is just going to be 2 units above the line of reflection. So that's D prime right here. F, you can see right here, is 7 units below the line of reflection. So to find its image, I'm going from that line of reflection up 7 units. So all the way here. And so that is going to be F prime. And our last point is E. E is over here, and it is also 7 units below that line of reflection. So to find its image, I'm going up 7 and plotting my point. And like I said, that is going to be E prime. So we can go ahead and connect there to get our image. And just like before, we could fold on that line of reflection, and that would help us to see that our images really are mirrors of each other and they really do match up. Our next step is going to be just like before, we're going to kind of compare to see what happens to our x and y coordinates. So in our pre-image, we had triangle D, E, F, and point D is at 2, -2. E is at 7, -7. And F is at 2, -7. In our image, in the reflected triangle, we have D prime, E prime, and F prime. D prime is at the point 2, 2. E prime is at the point 7, 7. And F prime is at the point 2, 7. So here for this one, when we go to describe the pattern, our x values stayed the same. And our y values, when we look at our y values, -2, -7, -7, 2, 7, 7, they just flipped in sign. Those y values, when we translated them, they just changed in sign. So the y values changed sign. So when we go to represent that algebraically, again, that means as an ordered pair. The x value did not change. It stayed the same. So that's just a plain old x. It stayed the same. The y now changed in sign. So that's, again, like multiplying by a -1. So that's like a negative y. So let's say negative sign there in front of that y. All right, go ahead and flip now onto the back. And there is one problem here on the back that we're going to kind of do together. I went too far there. So number 3 and 4. This is kind of the same problem here, 3 and 4. We're going to go over this one together. This will be the last one that we do here on the video. It says reflect triangle PQR over the y-axis, then describe what happens to each of the coordinates. So we are reflecting this over the y-axis. That's our vertical axis. And this is very much like what we just did on the front. So point R is 2 units to the left. So to get its image, we're going 2 units to the right, and that is R prime. To get P, we're doing kind of the same thing. It is 7 units to the left. So to get its image, we're going 7 units over, and that is P prime. Q looks here like it is 1, 2, 3, 4, 5 units from the line of reflection. So I'm going 5 units the opposite direction and making my point. So that would be Q prime. And I can connect then to get my image. But then the next thing it asks us here in this part 4, it says reflect your new triangle, P prime, Q prime, R prime, over the x-axis. Then describe what happened to each of the coordinates. So now we're taking that triangle that we just reflected and we're reflecting it again. And this time we're reflecting over the x-axis. And so this is going to make like a second image of that original triangle. So when I reflect here, I'm going from R, and that's currently 2 units above our new line of reflection. And so my new point is going to be 2 units below the line of reflection. Okay, and so now when I label this is the image of R prime. So when I label it, I'm actually going to label it R double prime with 2 prime symbols. Okay, P, the same thing. Now we're going 2 units below this line of reflection to get point P. And I'm labeling it the same way. This is the image of P prime, so this is P double prime. And for Q, Q is 7 units above the axis. So I am coming down here 7 units and making my point. And again, that's going to be labeled now Q double prime. And so then we can go ahead and we can connect that triangle to get our second image. And the last thing we're going to do is it says describe what happened to each of the coordinates. Well, if we look at just from our first image to our second image, you can see that it happened just like we said on our last example, that our x coordinates stayed the same and our y coordinates flipped. But when we look at the second image compared to the original, you can see that our coordinates are all opposites. Like, for example, if we compare point R at the point -2, 2 to its second image, R double prime, which is at the point 2, -2, we could see that both the x and the y coordinates changed in sign, which makes sense. We know when we went over the y-axis to get that first reflection, when we did that, we know that the x value changed sign. And then when we reflected again, when we reflected over the x-axis, we know that the y value changed in sign. So one important thing here for you to kind of see, and we can kind of even go back and talk about this on that last example that we did, it really depends which axis you are flipping over. When you flip over the y-axis, that coordinate stays the same. When you flip over the x-axis, that coordinate stays the same. So that's a good pattern for us to pick out here, is that whichever axis you're flipping over, that coordinate stays the same and the other coordinate changes sign. All right, so that's the last example that we were going to do together. You guys have 4 problems left here on your page for you to work on. So once you're finished with your notes, I want you to go ahead and see if you can finish these 4 problems, 5, 6, 7, and 8 on your own. I think that you can use what we've just talked about in these last few examples to kind of finish those up. If you do have questions while you're working, look back at your notes or send me a message and I'll get back to you as soon as I can.